Hello and welcome to another tutorial. So this time we are going to be continuing to build on the Procgen Mesh terrain. So this is a version of procedurally generated environment where rather than using Unity terrain, we're actually using a mesh, which gives us a little bit more control over things than we get with the terrain system. Doesn't mean we also lose a bunch of things as well. So there's costs and benefits on both sides with it. But where we got to last time, if we take a look, we had this set up so that we had all these different sections. And so we actually had different objects, and those objects could neatly stitch together. So it meant that if we wanted to have effectively an endless world, we could do that by continuing to spawn M1s. And as long as the location was being set correctly, we were going to be able to have those be nice and consistent and seamless there, which was great. So what I want to do this time in terms of changes is this is currently using vertex colors. So I want to actually support using either vertex colors or generating a texture. So I think it's good to have support there for both, because if we've got a texture, that's something where in a shader, we could actually be sampling more of the texture, we could get more intricate effects than is going to be possible with something that's purely vertex color based. So that's going to be the first set of changes that we make. The second set of changes, at the moment, the way stuff like hide and painting and that happens, it's all sort of very manually controlled, built in there. I want to make this so that we've got a bit more option there in terms of how it's actually generating that, and set up a little bit of a framework for being able to extend that going forward. So let's start by getting the texture side happening. So this, we're in a reasonably good spot with this because we've got a lot of the things we need already. So what I'm going to do is on the tile, I'm going to give this a enum, and this will be the painting mode. So we'll have vertex color will be the default, or we'll have texture based. I might call it, yeah, texture based. And then I'm going to put that up here. So we'll have height stuff, we'll keep grouped together. Height. Always good where you can to just make use of things like the header options, that to group things neatly does keep it better organized, makes it easier to use in the inspector then. So painting. So we've got our painting mode. And so we'll keep vertex color as the default. But then what we'll do is, so we can see down here, and we can get rid of our sort of general to-do because we've already got some basic painting happening in there. This generates the vertex colors, and we do assign that to the mesh. What we want to do is we want to actually turn that into a texture. So we can do that fairly easily. Now the mesh here, we've already got UV coordinates. That's something that we would need if we're going to texture it. So if we're texturing it, we want to have UV coordinates, unless we're doing the UV calculations in the shader, which can be done. But in our case, we're not doing that. We want to just have it be very, very simple. So what I need to do then is actually just put together the texture. So this is going to be a texture 2D. Well, the texture resolution doesn't have to be the terrain resolution, because our UV coordinates, things like that won't change. So this is something where I'm actually going to have texture resolution as a separate thing. Reason being is that it doesn't need to be linked to the size of the world. We could have it be the same, but we could actually have it be finer, and there are processes, algorithms we could run there to actually generate a more detailed texture. That's the other advantage we get from using a texture compared to just vertex colors, we can get a lot more detail in there. So I'm going to have, similar to what I did here, and I will actually steal these. So I do want to be able to control this independently, which is why from the very beginning I'm setting it up to be independent, because we don't want it to be linked. This will be texture resolution, and we'll default it to, there's no reason not to default that to essentially the highest one. So, okay, but that could be different to the size and scale of everything else, but that's okay. So what we're going to do first is our base texture, our sort of starting point for this. So our initial texture, that's going to be a new texture 2D. Width and height wise, well, that's going to be numverts per side by numverts per side, because that's how many colors we're going to have there. Texture format, well, with this, we don't need alpha in it. So I'm just going to go for RGB 24, and then I'm going to let it have a mip chain. So I'll say true. There's no reason for it in this case. I think that's completely fine for it to generate mip maps. Now for setting the content of the texture, so we should be able to do a set pixels where we give it, with set pixels, we can just give it the array of colors. So we can go vertex colors. Now we need to do apply. So this, we're generating the initial texture. Now we only want to be doing this if we're in that particular painting mode. So we're going to check if painting mode is texture. I want to actually rename that. That should be texture based. So we generate that texture. Now, if the resolution of the two is exactly the same, then this is quite straightforward. But if they're different, then that's going to change what we actually have to do. So texture 2D, final texture. I'm going to set that to initial texture to start with, and then check if our texture resolution, so if texture resolution is not equal to, we need to just check what the variable name here was. It's not equal to resolution. So this is our terrain resolution. So texture and terrain resolution are different. Then we're going to need to generate a scaled up version of that texture, or possibly a scaled down version of that texture, because we might have a really high terrain resolution, but we've set a very low texture resolution, or vice versa. So there's a lot of different combos we could encounter, so we kind of need to be able to potentially scale the texture up or down depending upon what we're working with. Now for resizing the texture, there are a few different ways of going about this. There's actually quite a few different ways. There's a very manual approach where you can directly create a new texture 2D, and then where you use, if you look on the texture, there is a get by linear, so you could use that. So looping over the content of the data, that's going to be typically a bit more of a slower process because there's a lot of things that's happening there. We've got options there, but we can also do effectively a bit of a render to generate it. That way we could also apply custom materials. So there's a lot of different ways that we can actually go about doing this. One of the other options is we can make use of, we have access to graphics.blit. Now Blit has a couple of things, but one of the key things is you can give it a render texture as a destination. So what that would allow you to do is can actually take something and output it to a render texture and then capture back from that render texture would be something that is doable. So how that would look, of what we would need to do, is target RT. So we need to firstly create a new render texture. Now with the render texture, in terms of setting this up, we've got a few different ones. We've got width, height, and depth. So we would use, in this we would provide our target size. And we know we're working 24-bit. So we set up our target render texture. We want to change what one is active, but what we also want to do is previous RT, just in case something might already have been active. So set up the temporary render texture and switch to it. So we keep that previous one, because that allows us then afterwards, render texture active is previous RT. So even if that was null, that still works for restoring things back. So just make sure we're keeping stuff in the same state that it was before. Then we should be able to do a graphics blit from our initial texture to our render texture. And with that, that should transport it over. Then what we can do is we create our final texture is a new texture 2D, set up the resolutions. We also can bring over the format and everything, same as before. Then we read back from that render texture. So we can do final texture, read pixels. We give it the area to be reading, which is going to be the entirety of the texture. And we need to make sure we do an apply afterwards. Now this also needs the starting location there for the destination to write it. So grab the texture. So that's good. Now we just need to update the texture that the mesh is actually using. So that's typically going to be underscore main text is typically what that is going to be. So once it's done all of that transferring, I would grab the linked mesh filter. And then I'm going to, in this case, we need to actually get the mesh renderer. So the mesh filter just holds the mesh itself, but I want to actually get the mesh renderer because I want the material. And then I want to be able to set texture. It's likely going to be main text. And we can set that to final texture. So what this should mean is when I select all of these, and I'm just going to change this one over to using the texture-based method. Now, when it goes to run, this shader at the moment, this is a vertex colored shader. So that one I'll call vertex color. Whereas this one, I'll say is textured. And this one actually can just return back to being just the default. We'll go for simple lit. And so then our texture here, Procgen tile. So this one I'm going to rename textured, whereas these are vertex colored, just so we can see clearly the difference between them, because we should generally see a little bit of a difference between how they actually look. So we've got those added in. So only one of them is going to generate the texture, the others are going to continue being vertex color based. So that is run. So we can see that it's got it's not applying any texture at the moment. Now, if we go and take a look at the material here, you can see it doesn't have this, so it's probably a case where the naming, okay, it should be base map because we're working in universal pipeline. So if you were doing this in the built-in pipeline, it would typically be main text, but because we're in the universal pipeline, that does change what it actually uses keyword-wise. So we can see that has come through. And we can see we've got the texture here, which can see the size of that. It's 512 by 512. Now it is going to look a little bit different because it is going through a different shader. So there is different stuff that is happening with it. But we can see that it's scaled it up. We could also test, make sure that it works for scaling it down. So we can see still works, so that is working really nicely. If I change all of these over to texture based and a similar resolution, so we'll make them all 256 by 256. So texture and vertex colored ones are generally not going to blend together nicely. Now we do need to also change the shader so that all the materials, so all of these are using the same material. So yeah, textured, vertex colored, they're not going to match together nicely, but our ones here are generally going to. Now we might need to do a little bit of tweaking at the seams there. We do get a little bit more of a seam with the texture-based ones. That's not entirely surprising. There's going to be changes we'd probably want to make in terms of the actual config for the texture. So there's things we could adjust here with the final texture for how it actually gets applied. So we can see we'll have stuff in terms of its filter mode. So we can also adjust things like its wrap mode. So we've got a few different options there. I would say we generally would go with clamp. So you can see how that looks. Changing the filtering there should mean that we get a little bit of a smoother look to it. And we can see with making those changes, it's still very, very slight, but it is much, much harder to see. And with applying sort of a bit of tweaks and decoration on top of that, we'd largely be able to sort of obscure those boundaries. It's inevitable when you've got the connections there, you're going to get some visible seams typically, but that's where we can do a lot of stuff to actually hide that with making sure we've got objects, things like that. Could also have a bit of a texture that gets, and this is something we could do in the shader, a texture that gets shared across all of them. So there's things we could be doing there to minimize those seams that happen there. So that's good. We've got our painting, things like that working better. What I want to do now is improve this so that we have some more modifiers, things like that, so it's a bit easier for us extending it going forward. So for setting up modifiers, we want to think about what our end goal with this is. And our end goal is to make it that we don't need to go to each individual tile to configure it. We want to have an object that a tile can link to that holds all of the configuration. That means not just stuff like the sort of size, resolution, things like that, but also the appearance and everything for it. So we want to be able to split that out, make that really easy to be working with. So I'm actually going to split things into two parts. One part that controls the general sort of broad structure. So things like our tile size, our resolution, painting mode, painting resolution, and max height. Keep those split off as a separate thing, and then have stuff that's involved in the actual generation within a tile. So it's controlling that stuff, split that off separately so that we could swap that in and out, and it's still going to generate things that are compatible with the surrounding ones, but it's going to do so, using easily accessible settings. So the easiest way to do stuff like this is typically going to be, what I want to do is use a scriptable object for the configuration. And so the settings I'd be moving over to the scriptable object. These would be things like our resolution, painting mode, stuff like that. And then things like the height, noise, and scale, move those into the modifiers. Same with stuff for the painting. So that's sort of the split that I want to do with this. So let's start to get our set up here. So we want to have our Procgen Config. So we'll do the configuration first. So first thing we're going to do is this becomes a scriptable object. So that means we want to have our create asset menu. So we set up our menu name first. So Procgen Config, and then we're going to have our file name Procgen Config. So what we can do is pretty easily bring these settings. We'll actually initially just grab all of this and bring it over, but we won't have the height, noise, and scale. Those will keep where they are. These ones will keep here. So that's good. These can become public because the whole reason for this thing existing is just as something to easily access the settings. So those can change. Now these enums, because of how we're working with them, I'm going to actually make them something that's public and fully available here outside of the class. They're quite closely tied to the class, so I think that's fine. I will do a little bit of renaming because I think that's important. And what that means is then our settings here, well, we're going to have a serialized field for our Procgen config. Then we've got all of these ones now that we don't need to actually set them up on this. So what I'm going to do, and this is something I've used before as a way of easing the process of transitioning code over, is I have these like this, and then each of these can just become a little accessor, keeps majority of our code exactly the same as what it was. So very little of the rest of the code actually changes, but it's now going through our configuration, which means that we've got this working a lot better straight away. So that's good. So there might then be a couple of things we need to update. And this, I'm going to also rename these to terrain resolution just for consistency. So that's good. So if I go and take a look, now there might be a couple of little bits that I might need to update, but potentially not. So that's good. So that means data-wise, I can come here and create a new, and then Procgen Config. 200 was already what we were wanting to be using. We're going to switch this over to texture-based. So that looks good. So that means all of these tiles now just link to that one config, and the rest of the stuff will just work. So it should mean I run this, everything loads, and we can see our terrain properly, which we can. So that's good. So the next step is the modifiers. So the modifiers are going to be different classes, things like of that, going to need multiple of them. So Scriptable Object is not a great fit for that. That's something where what I find tends to work better is you have a prefab that has the different modifiers on it. That works a lot quicker and easier. It tends to be a bit of a cleaner setup for it and generally easier to work with, I find. Well, let's start building up the infrastructure for the modifiers. So we're going to have a bunch of different ones. There are going to be ones that might manipulate height. There are going to be ones that would manipulate the texturing. Generally, the way I work with these is I would do these in different passes. So I would have a height pass, I would have a texturing pass, so I treat them as something that happens in isolation. Doesn't strictly have to be done that way. There is nothing saying that we couldn't have different passes operate on the same set of data actually. And that's something where that could actually validly apply. Like you could randomly apply some textures initially, and then based upon that, that might guide and impact how you change the terrain. So what I'm actually going to do is I'm going to set up a base modifier. So the idea is the base modifier is going to represent the sort of information and the base sort of requirements of what we need to be doing. So they won't have start or update. Now to work out what these need, if we look at our generation, so not the mesh generation, but stuff here like the height and things like of that, these are ones that are going to be working on the particular data and that need to be able to manipulate stuff. Now, if we look at what we're doing, we generate the height. UVs actually can happen earlier. So we generate the height. Then we're constructing the mesh and creating the normals. And then we're doing the painting. So what I think we could do with these modifiers is have essentially a pass that they run in. So a pass where we have height information, and then a pass where we have normal information, and then a pass where we have height normals. So we can indicate where a particular modifier should run. So I'm going to have an enum here, and this will be Procgen phase. So we're going to have initial, post normals. Actually, post normals is probably the appropriate term for it. Post normals, and then we call it after normals, and then post process. So what I will do is a modifier is going to have a phase that it is assigned to. So Procgen phase, and we'll call that phase. And we'll make an easy way for being able to access that. So that's good. So it'll have a phase that it runs in. In general, a modifier probably is going to also have an intensity. We'll default it to once. We'll default it to having full impact. But that's something where there'd be a lot of cases where having that intensity could be quite useful. So we'll need to be able to retrieve the particular phases, but that's okay. But this gives us, we can see, okay, painting probably has the most set of stuff in there. So this is going to give us the sense of what are the things we actually need. We also have this texture. So the post-process thing will potentially include a texture as well. So I'm going to use this as our reference point here for what the modifiers function is going to look like. So this, I'll make this abstract void execute. So it won't have any body to it. So it's going to look like that. This becomes an abstract class, which it should be. So numverts per side, that's useful. The vertices, things like of that. We also want to have it provide the Procgen Config. So a couple of other useful things there. So Procgen Config would be great to include. Would also be useful to include the tile. Now, in terms of where we have that tile information from very early on. So Procgen tile, that way we can get location information if we need, handy to have. And the final thing we might need to have, texture 2D, texture. That looks pretty good. So what we then do on a particular tile is we'll have another serialized field, game object, and this is going to be the modifiers. And that will contain all of the stuff like the height information, things like of that. So all of the different ones that we have there. So how this will then work is, well, perform mesh generation, that's doing all of the general base setup for it. But then this one where it's doing the height change. So here, what we would do is we would say, okay, well, our modifiers get components, and we want to get base modifier. So for all modifiers, and then for each modifier and modifiers, f modifier phase is equal to initial, then modifier execute. We give it the numverts per side. We give it our vertices. Now for the vertex colors, we have allocated that at this point, so we can provide the vertex colors. The normals we don't have at the moment. Now we'll get probably cranky at us providing through a null, but we'll come back and address that. Config and this. So we actually did get away. In some cases I've found arrays that can get cranky if you provide a null, but that's good. So run the initial generation. So this will slightly change with each of the different ones here. So where I go to do the painting here, this will instead then, because this is after normals, so we can actually now provide through the vertex normals, but what I will do is vertex normals mesh.normals. I'm caching it. I very, very, very specifically do not want it to just always be providing through the normal, accessing the mesh normals, because that would actually be quite bad for performance because it would extract that data. So you don't want to be continually accessing it. That will actually cause issues. So that will then do the setting of the colors or the updating of the texture. So that's good. And then the final one we'll do right at the very end here is run. So post-processing. Now we might not actually have anything that we're doing for post-processing. So this will generate the color information. We don't have that texture, which is fine. Here we generate the texture. But what I'll do is I'll put this up here, default it to null. That way, I can still use it down here if I need. Final texture, because I could still modify that texture. That should be okay. So that looks good. Final post-processing can run. Excellent. So then these, the height and painting, can be moved over to their own actual script. But I can also, in data, create, and I'm just going to create an empty prefab. Procgen Modifiers. And each of these gets linked to that. So now onto this modifier object, I'll just attach the particular bits of code. So I'm going to set up here modifiers. So I have a height modifier, and noise, which is what we've already got. And then I'll set up one for just a very simple painting, which the painting we're currently doing is just based upon the height there. So we'll set up paint modifier, simple height. So we just then attach those onto the actual prefab. So I select my prefab, these get attached on. We will then set these up so that they are using the new class that we've created, and then we'll transfer the settings over. So base modifier for both of these. That means they need to implement this function. So in both cases, it doesn't actually need to be override, I think. It does need to be override. So that'll be good. That'll be our painting one, and then we'll do a similar thing for the noise-based height. So then we can take our setup from here. So the painting, we'll bring that over. And this, well, we can go config max height. So that's part of why we pass through the config, to make it so it's very easy for us grabbing that stuff. So that thins out that. Then we'll do a similar thing with the height for its generation, but we get rid of that. So it simplifies our Procgen tile a bit as well, which is also good. So it's got the config in here, and it also means the settings that we have here in the tile. Now I'm not going to delete these initially because I want to be able to bring them over. Now Perl and Octave, I'm going to leave configured there because I think that's something where we would potentially be wanting to use that in a few different places. But I will bring these settings over, not deleting them from the other file yet, so that I can easily access the values and transfer them over. So this can access my sizes. So it's not too much to convert it over. It's part of why I passed through the config. It gives us all of that information. And then we can quickly check these settings here. I can copy those And if I go to the modifier, then I can paste those in, update the scale. Now this one does run in the initial phase, and then this one runs after normals. And that should mean, and check the modifiers, those have got all the data, so I can delete my settings from the actual tile itself. So it means our tile setup becomes significantly simpler, and the logic is self-contained then, which is ideal. That's sort of what we want. So if I test with that, then we can see it's still not quite working exactly right, but that's because there'll be a couple of bits that we have changed. See here where it's using just transform. So what we actually want to do is our origin point is tile transform position. And then we adjust these to use that. So that was just something where, to be expected, there was going to be some things that, and that's the thing, when you transfer stuff over, most of the time, making the changes in this way, it will break things in such a way that you do manage to catch all of the changes, but it's not always going to be the case. You will get some things where it won't. And so with that, we've now got it that we change one thing on the config, and that will change everything else. We can easily adjust things like our noise here, and that's able to be done without having to go to every single individual tile, which is good. And it makes it easy for us then setting up further modifiers if we wanted to. So if we wanted to set up a modifier that for the painting is using noise for that as well. So we could do a paint modifier that uses Perlin noise. For that one, well, we already know what the general structure is going to need to look like. So we can do that. Now with this one, much like with the height one, we want to have some configurations, but the configuration is going to be a little bit different. So whereas with the tile one here, going to bring this over, and I'll call this textured, because this could then paint in a particular color. Actually, I might call this colored. So this will have public, color, and octave color. So then we can set up a list of these here. So we'll have a list of our colored colors. And then we would also, alongside this, we want to have just a base color. So with the colored Perlin octave, we don't really want the all of these settings here. What we want to have is a scale. So we want to have a scale for it. We want to have an intensity and a threshold. So the threshold and the intensity are going to control how strongly it gets applied. So those are ones that will make those a range. Those can both be range ones. Scale is going to control just the overall scale of the noise, so that we don't really want it to be just a 0 to 1 range. But okay, so that looks good. What we would then do is we need to work out the colors to potentially apply to this. So it means we need to work out the noise at a location. I'm just going to rename this because we're going to use it less in an octave approach and more as just a particular noise config. So colored noise config. So what we want to do is we want to work out which one to actually, what to actually apply to this. So we need to get the Perlin noise for a particular location, and we need to go through each of the ones. So what we're going to do is have color, vertex color is our base color to start off with. And then what we're going to do is go through each of these configs. So var each, I won't call it config, we'll call it color config in configs. So then with that, we need to generate the noise value. So we need to do a mathf Perlin noise, and we have our row multiplied by our scale here. So color config dot scale divided by, and we'll do numverts per side -1, so that it's a 0 to 1 range there. Then we do the exact same thing with the column. So this is the noise value. So that uses column. Then we need to check if that noise is above the threshold. So if noise is greater than or equal to our color config dot threshold, then we can apply this color instead. So what we would be able to do is we could do something like our vertex color is equal to, so we've got a few different ways of how we could do this, but we could do something like, and this will be an interesting one to check out, doing a color lerp from the current color to, and we might rename that to just a color, I think is fine, or noise color. And that, we have the intensity. So that will blend it over. And like that. Now, we might want this to work more seamlessly across the tiles. So that's where if we take what this does, we'll be more able to achieve that. So the noise values here, well, we can see what it was doing in terms of how it was adjusting this. So origin point gets added in. So I'll actually bring over this row progress and we'll do this pretty much the exact same way that the height one does, because we already know that the height one works quite well for keeping things in sync. So then this is going to be, well, multiply that by row progress and by column progress. And then this, we don't need to do any lerping there because we're just directly calculating the color. So this way it should mean that the colors uniformly merge and blend across the tiles, because we're doing this process where we're getting a 0 to 1 value and then we're offsetting it by the actual world location of the tile. So it should mean we get something that is continuous there with the texturing, which is ideal. That's what we want to be able to achieve with it. So I'm going to bring over to the modifiers. We're going to add in our Perlin noise painting, which I'm going to remove the simple height script. This does run after normals. Now the base color, I'm going to set as being sort of a, yeah, that level of green. low transparency. Now configs, let's set up just 2 configs. So I'm going to add in maybe some brownish patches. Looks good. Now intensity for these, I'll say 0.25, threshold similar. Scale, might go with 8. Then I'm going to also add in maybe some dark greenish patches, almost sort of swampy looking. That looks good. Again, scale, we might go 16, so we'll see a bit of a difference probably between these, and 0.25 for both. So let's run that. This is a bit more of a complicated painting modifier. But we can say we get our patches and they're continuous across the segments. And it's a lot harder to actually spot those seams now. We can still just spot them if we look closely, but they are a lot harder to spot. And we have this sort of greater patchiness to the terrain there. That would also mean I could try different sort of settings there on this. So that was using 8 and 16. Well, what if I lower both of these a lot? You can see what that does appearance-wise to these. You can see patches tend to be a little bit larger. We could also adjust the intensity, so like the more sort of muddy looking patches there. The higher that intensity is, the more it's going to move towards that color. So we can see it gets a lot of areas where things are above that threshold. So that's something where I could raise that threshold quite a bit. So we just get more isolated patches. So with that, we've just got isolated little patches that happen, but in those patches, the color comes through quite strongly. If I change that scale, so let's make the scale really large on these, just so we can get a bit of a sense of what actually changes with those. So larger size there means we get smaller patches. So that's something where whatever size we set that to, that's going to heavily influence the kind of texturing we get there with the terrain. So we can get it being a bit more speckled like that. If I lower the size of those quite a bit, so we might actually go all the way down to like 4. You can kind of see what happens when we've got the scale quite small like that. So we can see we get quite large patches. So smaller the scale, the larger the patches, larger the scale, the smaller the patches. But this gives us an infrastructure that we can be using to easily control and modify how the terrain looks. And although this is running in its textured mode, if I switched it back to vertex color based, and if we switched the material here over, then we'll still get something that works. It's just going to be using the different material. So it's still working, still behaving exactly as we would want it to. It's just that we've got now the option of whether we're going vertex mode, vertex color based, or whether we're going texture based. We are still setting the vertex colors no matter what. So even with the texture based one, we could be doing a shader that is using information from that vertex colors and also from the texture that we've generated as well. So we've got the option there for both. So it gives us a setup now where we can easily go and modify these. We can change just in one spot the settings that will affect all of the different ones that we're spawning in, and we've seen how we can have it that not just the height side but also the texturing side can be made a little bit more seamless so that we can be blending them there together quite nicely, which is great. That's stuff that really helps out with the visual quality there, and we'll always still get little bits of seams there. That's an inevitable thing. It can be very hard to avoid that, but we can distribute things in those sections to try and minimize and break up those potential seams, which is really handy. Thanks folks, hope you found the video interesting and helpful. If you have, then chuck in a like and subscribe. It's something that really helps out, it's really appreciated. If you're looking for the code for the project, that code is available up on GitHub. You can be using that in any of your own projects, commercial, non-commercial ones. You're free to be using it. If you've got any questions, chuck in a comment below. And if you are looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description below as well. But until next time, bye.